Hey guys, last week you did an excellent job working hard with volume, with talking about rectangular prisms, specifically when we were working with composite figures. I saw a nice job of being able to break the objects apart into two different prisms using the volume formula and adding them together. That is a really tricky concept. So if you still don't quite understand it, that's okay. Um, it's just one of those things that I wish I could be there in person there to support you. But obviously, we're doing the best that we can through online learning. But this week, we're going to be focusing on one of our last topics of the school year, and it is going to be geometry. And we're going to be talking about different shapes and the way you can classify or put shapes into different categories based off of their character traits. So we're actually shifting gears. Last week and the week before, we were focusing on volume, and volume is anything that's three-dimensional has volume. But we're going to take a step back and we're going to be looking at planes. So a plane is a flat surface with no thickness whatsoever. So it just has a length and a width sometimes. And it's two-dimensional or 2D. So you'll see here an example of a 2D plane shape is a square. A special type of, we're also going to be talking about this keyword polygon. Hopefully that's not unfamiliar to you. You should have heard this word before, but it is a plane shape having three or more straight and closed sides. So all of these are examples of polygons. Are all these shapes examples of polygons? Well, let's go ahead and look at them. These are all different types of polygons. So you can see that they have straight edges. There are at least three sides. There's no curves. There's no open spaces. It's all enclosed. So yes, these are all examples of polygons. These shapes are not all examples of polygons. So you'll see here we have a heart, which is curved. This is just like a line. It's open here, so it's not closed, which means it's not a polygon. A circle has curves instead of straight edges, so that's not a polygon. A line does not have at least three sides, so that's not a polygon. A polygon must be a plane, which is two-dimensional, so a cube is not a polygon. So the only two polygons we have here is a triangle, and this one has four sides. This is called a quadrilateral, and more specifically, you could call that a trapezoid. So we're going to be talking about triangles today, mainly, but I do want to let you know, let's review this word congruent. It means that it's the same size and shape. So something is congruent. It doesn't matter if it's slid or turned or flipped. The same shape and size means that it's congruent. And we're going to be talking about congruent lines a little bit later. So we are going to be focusing on triangles today. So in other words, we have this idea of polygons, which are these at least three sides. They're closed. There's no curves. And this is a category. So we're actually going to be talking, it's called a hierarchy of shapes. So in other words, we're going to be looking at categories and we're going to be breaking the categories into more specific information or character traits or attributes or properties. So you may hear all of those words. So anyway, we're going to be focusing on polygons. This week, we're going to be focusing on two different types. Today, we're going to be looking at triangles. And later, we are going to be looking at four-sided shapes, which are the quadrilaterals. So today's focus, once again, is a triangle. But I do want to point out to you this idea or this concept of a hierarchy. So in other words, we have a polygon, which means it has three or more sides. We can split them into more specific categories where we have a triangle, which has exactly three sides, and a quadrilateral that has exactly four sides. So these are called subcategories of the hierarchy because it falls underneath the umbrella of a pentagon, but it's specific. So a quadrilateral is not a triangle, but it is considered a polygon. So once again, we're going to start off today with talking about properties of triangles, how we classify them or name them. Hopefully some of them are familiar to you. So we're going to start off with a fun video, and I have a friend, Mr. C, that's going to help us learn about the different ways to categorize triangles.
Mr. C is gonna teach you about the triangle. Triangle only have three sides. Triangle 180 degrees inside. Triangle, so many different types. Triangle, it's time to bust a rhyme. So first, let's talk about the different sides. Equilateral, isosceles, and scalene types. When you look at them closely, almost like a different shape. It's all about the three sides, make no mistake. Equilateral, all sides are equal. So perfectly created, it should be illegal. When you check it out, you're like, they all look the same. La-di-di-da-di-da, equal, that's the name of the game. And isosceles, like a nice tall tree. You'll find two equal sides, but never all three. It's like a little tower with a beacon above. The third side is different. Yeah, I think I said enough. Lastly, scalene a little wacky different. Each side a different length to know you're not tripping or slipping or falling, getting stuck on the shape. Scalene triangles have three different legs, so many types, and you need to believe that learning triangles is easy here with Mr. C. So everybody, it's time to join the flow. The chorus teaches nifty things about the triangles. Triangle, only have three sides. Triangle, 180 degrees inside. Triangle, so many different types. Triangle, it's time to bust a rhyme. So next, we really have to recognize that each has 180 degrees inside, and the sum of the angles always adds up the same. Plus their angles, give them different clever names. The acute ones first, snugly cuddly bear. Every angle less than 9 degrees, but be aware, those angles may look small, but they pack the same big punch. When you add them all together, it's looking pretty tough. Obtuse, the one angle's fairly large, greater than 90 degrees, thinking it's in charge. But when you realize that's part of the game, just add them up and then you'll see it's gonna be the same. Then the right, think I said enough. 190-degree angle and it's looking pretty gruff. Standing there showing off the box inside, which reminds the other triangles, it's always right. So many types, and you need to believe that learning triangles is easy here with Mr. C. So everybody, it's time to join the flow. The chorus teaches nifty things about the triangles. Triangle, only have three sides. Triangle, 180 degrees inside. Triangle, so many different types. Triangle, it's time to bust a rhyme.
So today's focus is going to be talking about the different types of triangles, like Mr. C said. And hopefully by the end of this video, this little joke here, if you don't get it now, makes sense. So this says, why is the obtuse triangle always upset? This one says, because it is never right. And here we have a triangle that's crying. So we're going to revisit that one at the end and see if it makes sense to you. So once again, just to kind of summarize what Mr. C introduced here, there's different types of triangles and you can classify them by their side as well as by their angle. So I would like you to pause this video and go ahead and copy down the pictures of the triangles as well as the vocabulary words, because that's going to help you when we get to our later in the activity. So if you're going to classify a type of triangle by side, we'll see here that an equilateral has 3 equal sides, an isosceles has 2 equal sides, and a scalene triangle has no equal sides. Mathematicians came up with a way to help show that something has an equal side. And that's what these little lines are for. So these are called congruency lines. And just like we talked about, the word congruent means same size and same shape. That's what's going on here. So the fact that all of these sides show 2 tick marks, that's a mathematician's way of saying these sides are all equal. In the isosceles triangle, you'll see that they have 2 hash marks on 2 of the sides, and that's to show that they're both equal. This third side then is not equal because it doesn't have the 2 hash marks. And then lastly, with the scalene having no equal sides, they didn't put any hash marks on there because they don't need any because the hash marks show congruent sides. Now, you could technically put 1 hash mark on this side, 2 over here to show that they're not equal, and then 3 over here to show that that's not equal. But I did want to show you that congruency sides are important because I don't like classifying triangles by sides unless they're literally telling me by writing down the length. So maybe it'll be labeled all as 8, or showing me by making the congruency signs on there. You can also classify the type of triangle by the angles. So in this case, we have an acute triangle, which has three angles that is less than 90 degrees. So you can see that a 90-degree angle looks like an L. All of those are smaller than an L, which means they're less than 90 degrees. The right triangle has one 90-degree angle. Once again, when you're looking for right triangles, I always look for that square in the corner. That tells you that's a mathematician's way of saying, hey, this is right. And the last one is obtuse triangle, where I used to think of obtuse as like similar to a beast, obese, which means it's greater than 90 degrees. So in other words, this angle right here is wider than the L shape, which means it's greater than 9 degrees. So this would be considered an obtuse triangle. So you can actually classify triangles just by the sides, just by the angles, or by combining both of them, which is kind of what we're going to be looking at today. So for today's assignment, we're going to be looking at some different types of triangles, and we're going to be classifying them. So what I decided to do is we're going to kind of work on this together. Oh, I'm going to pause the video so that I can make this so that I can draw on these, because I just realized I can't draw. Okay, so we're going to go ahead and look at some different triangles and how we can classify them by their sides and by their angles. And then you're going to be practicing this within the Edpuzzle video. So I'm going to try and blow up these triangles as best as I can so that we can look at them together. So the first thing I want to point out to you is we're going to start with the angle first by classifying by the angle and then the side. I don't know if that's the proper way to do it, but let's just go ahead and look at this one. So we have a triangle here. I'm saying that this is an acute triangle because if you look at all the angles, all of them are less than 90 degrees. This one is isosceles as well because these two congruency lines, since there's one on each side, tells me that those sides are equal, and two sides equal in a triangle is an isosceles. So this is an acute isosceles triangle. This next triangle we have here is first obtuse. The reason why it's obtuse is because this angle is wider than 90 degrees angles. And I wrote scalene because if you look at the lengths of the sides, all of them are three different sides. So there's no sides with equal length, which is a scalene triangle. So this is an obtuse scalene triangle. Here we have a right isosceles triangle. This little square in the corner is my giveaway that it's a right triangle. And then the fact that I have two congruency lines on either side is showing me that it is isosceles. So if I do not have any, well, actually, I think we'll have one of those right here. Yes. So this is an example of a right scalene triangle. So once again, I see that it's a right angle because my angle is a 90 degree. There's a little square in the corner. It's scalene because all of the different sides are different lengths. So now what I'm going to have you guys do is for your lesson today is the next series of questions are going to be you classifying the triangle. So I'm going to go ahead and allow you to answer. And and I'm going to just kind of talk through the answer. I'm not going to take the time to write it. So this one here, if I'm looking at the angles, they're all acute. They're all not less than 90. So this is an acute equilateral triangle because all sides are equal because of the tick marks. This one to me looks like acute angles and all of them are different size. So we have an acute scalene triangle. This triangle here looks like this is a greater than 90 degrees. So that's going to be obtuse. And then I have my two hash marks. So that's an obtuse isosceles triangle. This one's acute equilateral. This one's going to be a right angle, and then there's no tick marks here. So we got a scalene triangle, acute scalene. We have two sides with equal length, and we have a right angle here. So this is right isosceles. Ooh, this one's giving me the angle measurements. So in this case, since this is greater than 90 degrees, I know this is obtuse. And I don't see any lengths. I don't see any congruent lines. So we have an obtuse scalene triangle. In our last one here, we have acute because there's no less than 90 degrees and there's two sides that are equal. So this is an acute isosceles triangle. So now that we're at the end of the lesson today, I'd like to go back to my joke from the beginning. And I want you to tell me, let's classify these triangles. I'm not going to classify them by their sides because I don't see tick marks. And I don't like when there's no tick marks. But let's classify each one of these triangles by whether they're obtuse, acute, or right. So in this case, the little red guy is a right triangle. His joke is about the obtuse guy, and the fact that he's never right. Obtuse angles are never right because the fact that if you always have an angle that's greater than 90 degrees, you're not going to have a right angle in a triangle. It's actually impossible. So that's today with classifying triangles. And tomorrow we're going to start working with quadrilaterals.